and welcome to our mentorship mini-series. I'm Dr. Dan Kalish. I'm going to talk to you today about glutathione and methylation and how glutathione and methylation relate to detox capacity, hormone balance, brain and heart health. But really, the gist of this is to say that glutathione and methylation need to be connected to metabolic health and metabolic function, because 93% of the population right now has a metabolic problem, which means by definition, they have a problem with their mitochondria and their metabolic health, which means that they have a glutathione and methylation issue of some sort. So you're seeing this every day in practice. 90% of Americans plus have one of these problems, and it can be life-threatening or life-ruining. It can make you fat and tired and depressed, which is life-ruining, and it can make you make your immune system fail, like during the COVID epidemic, or pandemic. It can make your heart fail, you can have a heart attack. So this can be anything from a mild, I'm 10 pounds overweight problem to a, gosh, Frank just died from a heart attack. Why did that happen? He seemed so young and healthy, and he was on a run at age 53 when he died. So this is, a mission critical kind of area to know about, and something that you're seeing in your practice every single day. So what the heck, let's talk about it. I'm gonna get into a brief description of who I am and why we're here, and then I'm gonna talk over some slides and explain some biochemistry, which is what I think of as like applied biochemistry. It's the amount of the biochemistry you need to know so you can interpret the labs and develop treatment plans appropriately. And then at the end, we're gonna look at labs and design a program and figure out how you can really apply this stuff. So I am, for those of you that are brand new, welcome. I'm Dr. Dan Kalish. I've been practicing for a long time, since like the early 1990s, and we've trained thousands of practitioners here at the Kalish Institute. And the focus of the Kalish Institute, oh, by the way, this is our 20-year anniversary too, in case I forgot to mention that later. 20 years, I started the training program 20 years ago, 2006, which is pretty amazing. So during these past 20 years, me and my team have developed and built thousands of practices. I can't even tell you how many. It's just a wonderful experience to see functional medicine doctors that are new to the field coming in, learning how to do the work and applying it, and those that have been in practice for a while, taking our courses to get themselves better organized, better situated, get their flow working better, get their finances working better, get their clinical protocols more streamlined and in line with something that's going to actually be a profitable clinic. So I'm very interested in biochemistry, but I'm also very interested in all of us making a sufficient income so we can send our kids to college or whatever else you want to do with your money. You could buy a boat, I don't care, whatever it is you want to do, so that we're helping people and that we have financially successful businesses. Super important that we're doing that. And in honor of our 20th year anniversary, we are offering a $2,700 discount on the mentorship. So the mentorship program starts next week on January 12th. The mentorship program, this is like a mini mentorship session. So what we're doing today gives you little glimpses into what the full year is like. So in the result of taking the mentorship basically is that you learn how to read lab reports with confidence, you learn how to design programs, how to problem solve dealing with patients, and set all this stuff up in terms of a real practice with real dosages, with real products, real lab results. It's not theoretical at all. It's like, this is a supplement you should buy from this company, and give them 6 a day, and let's talk about it in 2 weeks, okay, and see how the person's doing. We also teach in the mentorship a more high-level approach to sequencing multifaceted programs, where you've ordered an adrenal test and a GI test and a female hormone panel and an organic acids test, and you need to kind of create an amalgamation of all of these test results into one integrated program. Know what to do first, how hard to push the person, what to do next, when to retest. It's a lot to juggle when you're doing multiple labs in a single case, which is really what you should be doing with everybody. So the mentorship is designed to be a program where you can integrate not only lab interpretation skills, but how you can interpret a series of labs in one case and then put that together into a program that's going to be clinically effective. And it's complicated. It takes at least a year. I mean, most people stick around more than a year, to be honest. and join our membership program, because it's a lot to take in. Just learning how to do each test is one thing, but learning how to combine them into a protocol that a patient can actually do is another thing. And then what's even more important, if you get that far, is a protocol that's actually going to change that patient's life, something that they're going to experience as significant in terms of how they're feeling and their symptoms being relieved. We have a resource library with thousands of case studies in it. We have the live calls where we review your labs that you submit, your cases that you submit, and then we have a series of lectures that you take throughout the year. So you're learning from the lectures, you're going to class. We have 4 hours of class every week. We've got thousands and thousands of cases that are going to be coming at you. Just depends on how much time you have to put into this. But at the end of the year, what I see are people that are confident in how to interpret labs, multiple labs across all kinds of different patients. We have 70-year-old patients, we have 6-year-old patients, we have everyone that you can imagine that we're doing workups on. And it's an exciting group of people to be working with. And it's been 20 years. I'm reflecting back on it. It's pretty amazing to watch people go from not really sure how to do this to being like, yeah, I got this. And at the end of the year, we've got people submitting programs, and I'm like, where did you get that? How did you know how to do that much thiamine? And they're like, oh, that was in lecture 5. I'm like, wow, okay, you're really listening and paying attention. People really get this stuff. They integrate it into their lives, and it changes their practices permanently in a very good way. Okay, so enough of that. We'll come back to that a little bit later. So what we want to talk about today is methylation and glutathione and how it ties back to metabolic health, because this is like ground zero for all the people that we're working with. And so we think about MTHFR. I am not anti-MTHFR. I'm just thinking, hey, there's a lot more to methylation than folate. And we're going to get into the details on that now. And this is from a very, what would you call it? A very biochemistry-driven viewpoint of a scientist, my main teacher in this work, Richard Lord, looking at methylation from the broadest perspective possible. And when you look at it from that perspective, which we're going to do today, it really changes your thinking process about how you approach methylation defects and glutathione problems in relation to patients that have metabolic issues, like they can't lose weight, they're tired, those kinds of things. So the first session in this 2-part series, we talked about mitochondria. When the mitochondria become damaged, we can't make energy. The heart, the brain, the liver, muscle tissue, we talked a lot about that. They need the energy, and we need to develop muscle tissue to make all this work. So now we're going to go back one step to more of the origin story to how that happens. And the things I would love you to understand and start to grapple with after today's talk are the connections between creatine, methylation, glutathione, and mitochondrial function and mitochondrial damage. If you can get that starting to percolate in your brain, then when you look at the labs, you're going to be like, oh, this marker connects to that marker, connects to this one, and that's why the person's feeling this particular symptom. So the highest level view that we can take now is going to be the role of methylation and glutathione and how they are intertwined. And it's kind of complicated, I guess. So glutathione is protecting your mitochondria. So as you're making energy, as the mitochondria make energy, they're creating oxidative stress. 90% of the oxygen that we're all breathing right now, breathing oxygen in, where is it going? 90% of it is going ultimately into your mitochondria to do that whole oxidative phosphorylation thing. Remember the electron transport chain, all that? So it makes sense if 90% of the oxygen is going to your mitochondria, that's where most of the oxidative stress would be, because oxidative stress is problems that we can develop in relation to being exposed to oxygen. That's where the oxygen is. And when we're making energy, or ATP, it's very much like, lighting a bonfire. There's stuff that's happening, there's sparks flying off, and they can, overwhelm our system if we don't have enough glutathione. Glutathione is like the fire extinguisher. The ATP production is like the sparks coming off. And the link here is oxidative stress. So the more energy that we make, which is a good thing, the more oxidative stress that we generate. Most of the oxidative stress in the human body comes from the oxygen in your mitochondria making energy. So if your oxidative stress gets too high, if it's excessive, then your body does a couple of things right away to preserve cells. It will decrease, you see the decrease there? It'll decrease this process, which is called methylation, in response to oxidative stress. Methylation slows down. Why? Because your body has to increase this process, which is the production of glutathione. Makes sense. You're under a lot of oxidative stress. Your body needs more glutathione. There's only a certain amount of all this stuff to go around, so your body slows down methylation so it can speed up this transsulfuration process, which is how we make glutathione. So these two processes, these two most important processes in the human body for cell survival, methylation and glutathione production, are in direct competition with one another. Two most important processes, this is according to Richard Lord. I've got a lecture on tape of Mark Hyman saying this too. It's not just Richard's ideas. Glutathione and methylation are two, if not two of the most important, if not the two most important processes in the human body for cell survival. And they're in competition with one another. The more glutathione you need to make to protect yourself from oxidative stress, the more screwed up your methylation gets. So right off the bat, if the person has a methylation problem, the first thing you should think about is, gosh, I wonder if it's because their glutathione needs are exceeding what the body can handle, so it's slowed down methylation. Now you could layer the genetic MTHFR thing on top of this if you want, and that would obviously just make the whole thing worse. But even if you're MTHFR happy, and that's all good, we're all still exposed to tons of oxidative stress, not just from internal production of oxidative stress from the mitochondria, but from environmental toxins, chemicals, and heavy metals that damage the system as well. We'll talk a little bit about that in detail later. But this is a basic scenario. So now with the lab testing, we can measure this entire process. You can measure methionine, you can measure homocysteine, you can measure serine, you can measure cysteine, you can measure B6, B12, folate, obviously. You can measure glutathione. You can measure pyroglutamic acid, which is a marker for glutathione. You can measure alpha hydroxybutyric acid, which is a marker for glutathione. You can measure glutamine. I think I already said glycine. Each one of these things I'm circling here now can be tested for. So we're not like wondering what's going on. This diagram that we're looking at was created by Dr. Lord because he wanted to get every single test marker that he was running in one place so we could see what the heck is the point of this. So once you lay this out on lab work, you can see how well is a person methylating, how well are they making glutathione, and if you try to fix methylation and you ignore glutathione production, you're missing the entire point. You could even make the person worse. If you're trying to speed up methylation and your body's trying to decrease methylation because of oxidative stress, that's not a great thing to do. You realize that? Does that make sense? So your body's pushing to decrease methylation because of oxidative stress and the need to make glutathione, and you're trying to increase methylation. What's that going to do? It's just going to screw up your glutathione production even more. And nature knows what nature is doing. So the reason why nature prioritizes glutathione over methylation is because glutathione is more important, okay? Because if you don't have enough glutathione, cells are going to die. Cells can kind of limp by in a horrible way if you're not methylating well. But the reason why your body prioritizes the production of glutathione is because it's more important. It's more important for cell survival. So you don't want to work against cell survival. You don't want to crank up methylation in someone who's low in glutathione. That would make them worse. That's against the rules. That's the whole do no harm model. We all signed up for it. Do no harm. Don't make people worse. Oh, and then just to reiterate, because these are like maybe some new terms for some of you folks, the markers that we're going to look at in the labs include alpha hydroxybutyric acid. They include pyroglutamic acid. And these are all markers for glutathione production. And depending on which company you're using, there may be some variation here, but I'll try to circle them all. We can measure glutathione itself. We can measure glycine, which is an amino acid, glutamine, and cysteine, and methionine. Those are all amino acids. You can measure homocysteine. You can measure B12, folate, and B6, all with a high degree of accuracy. Okay. And let's move on. I'm going to skip a lot of slides because I just put too many in here. But here's the next thing, just conceptually, you want to wrap your mind around, is that methylation is a genetic on-off switch, right? We methylate, DNA methylation. If you just type methylation into Google, you'll be reading about DNA methylation all day long. That's what people think of it as. So it's turning, genes on and off. That's pretty important. But methylation is also one of the detoxification pathways in the liver. So it's one way that we clear or get rid of hormones that we don't want or need anymore, or chemicals that are them onto things to get stuff done. And here's the methylation cycle that we usually think of right here: B6, B12, betaine, choline, methionine, etc. But those single carbons have to come from somewhere. So this is this is methylation as we usually think about it there. But you see that this diagram is trying to show that's methylation as we usually think about it, but it's part of a bigger picture. The only way that you can move carbons around through methylation is if you have an adequate single carbon pool. I love Dr. Richard Lord for so many reasons. In fact, I'm talking to him tomorrow, which I'm excited about. But one of the reasons I love him is I know that there was a meeting where they talked about this diagram and they said it's the single carbon pool. And he made a laugh and a wink and said, hey, let's make the color like my swimming pool. That's so cool. This is a pool. It looks like a pool, right? It's a swimming pool of single carbons. If you don't have the single carbons, there's nothing to move around and methylation completely falls apart. There is no methylation without the carbons. But where the carbons come from? I don't know. Did you ever think about it? Not really. Serine, glycine, histidine, glutamine, and tryptophan. There's 5 amino acids from which you get the carbons, which make up the single carbon swimming pool here. Then those carbons are what are getting slung around during the methylation process. So you can see where this is going. If you don't have enough serine, glycine, histidine, glutamine, or tryptophan, it doesn't matter how much folate you're pumping into someone's system. It just won't. It would be like putting gas into a car that doesn't have tires on it or something. You're just not going to get anywhere. It doesn't matter how much you could fill the whole car with gas. If it doesn't have tires on it, you're not going to get anywhere. This is like the tires here. This is like what you have to have. You have to have the carbon. That's what the whole point of methylation is to move carbons around. And that's amino acid dependent. So now, in order to see if someone can methylate properly, you have to test amino acids. It's like not an optional thing, it's a requirement. And you have to know the status of their serine, glycine, glutamine, histidine, and tryptophan. Okay, and just a quick shout out also, so I don't forget. As part of any good methylation program, you want to include betaine and choline. Betaine and choline. And sometimes when you're looking at supplement labels, betaine is going to be listed as trimethylglycine or TMG. So we can skip some of that. We talked about the cofactors. B6, B12, and folate are super important. Oh, and for those that joined us late, if you were in the mentorship program, you would have a whole series of lectures that talk about everything that we're talking about today, but in great detail. And then you would show up once a week to your lab time, and you would be submitting your patients' labs and your labs on you, and then we would be reviewing them and designing programs. So the mentorship is a hands-on program. A lot of the great functional medicine programs I see as like the medical schools. The Kalish Institute is like the residency program. It's where you roll up your sleeve, you start to look at labs, and you start to think, okay, what do I do? How much N-acetylcysteine do I give? And I see these programs every day. A mentorship student that's new will say, oh, and I gave them N-acetylcysteine. Okay, how much? 500 milligrams. Well, that's not going to do anything, is it? How about 4,000 milligrams? Oh, really? Yeah, that's what the lab indicates you should do. How much arginine should I give? Well, 1,000 milligrams. That's not going to even. You got to start at 3,000, and you might need to go up to 6,000. So getting you guys comfortable with what are therapeutic dosages and what are programs that are going to really work, that's the point of the mentorship. And now I can say confidently, we've been doing this for 20 years, and I love the graduates that we complete our courses because they really know what they're doing. In fact, a lot of them I'll meet a few years after they take the course, and they know a lot more than I do because they've gone on and studied, and they're smart people. They're people who take this information and run with it, and I feel like we have the best graduates in the industry. Bingo. Okay, so now, the nutrients that we have to look at are folate, B6, and B12. Folate, B6, and B12. Folate, B6, and B12. And let's look at lab markers for each of those. So for B12, on the lab test, you're going to see a marker called methylmalonic acid or methylmalonate. It's the same thing, methylmalonic acid or methylmalonate. If that marker is high, it means they're low in B12. You got to memorize these. For folate, the functional level of folate, is there enough level, is there enough folate in this person's body to function properly? That marker is called formiminoglutamate. Formiminoglutamate, or sometimes you'll see it written out as formiminoglutamic acid. That's really hard to pronounce, although I have trained myself to do it, formiminoglutamic acid. So everybody just calls it FIGLU because they don't want to struggle through trying to pronounce that. So FIGLU is the marker for folate. If it's high, your folate levels are low. It's the inverse kind of thing. If it's high, it means you're low in folate. Formimino, we don't have to worry about that. So here are the basic markers that we need to be thinking about. Methionine, homocysteine, glycine. Why glycine? It's one of the single carbon things, right? Histidine, betaine, choline. These are the markers that we need to be thinking about. And then on the side of oxidative stress that would be damaging the mitochondria, and on the glutathione side, we've got 8-hydroxy-2-deoxyguanosine, pyroglutamic acid, alpha-hydroxybutyric acid, sulfate, some of the labs have, and then we want to focus on these. These are the ones that you need to memorize, really. Let me just show you. So you need to know these: FIGLU, methylmalonic acid, and xanthurnic acid. The xanthurnic acid is a marker for B6. If the marker is high, it means they're low in B6. So here we have B6, B12, and folate. Those are the key markers you need to memorize. And then today, we're going to focus on these two, pyroglutamic acid and alpha-hydroxybutyric acid. Those are both signs of glutathione levels. Okay, and that's what we're talking about. But there's plenty of other markers in there you can see. We kind of covered all these things. I'm going to leave plenty of time for labs and a little bit of time for questions. So that I'm going to have to read this. This is directly from Richard Lord's book. If you want to get his book, just Google Richard S. Lord Lab Guides to Health. Richard Lord Lab Guides to Health. You can buy his book if you want. But I want to read this because it's kind of important. I'm going to put my glasses on and just take a minute to do this. Thank you, Richard, for writing this book. So, the complex subject of assessing an individual's methylation status will be approached in 3 segments. 1, dietary methyl donors and cofactors. 2, metabolic pathways. And 3, methyl transfer reactions. Why am I reading this out? Because it's complicated. It's more than you might think. Homocysteine is a pivotal compound of methyl group supply, and SAM or SAMI is a universal methyl donor. Impairments due to micronutrient deficiencies of folates or vitamins B2, B6, or B12 Okay, that could be part of what's happening. But it's more than that, right? It's more than that. Look at this, dietary methyl donors, glycine, serine, threonine, choline, betaine, all these have to be present for the system to work. It's more than just folate, quite a bit more than just folate. I won't read all this stuff out to you, but you can get the book. Now, I'm going to read a little bit here because this is super important. And this is your secret trick that I'm teaching you now. This was brought to us by one of the mentorship grads about 6 months ago. I didn't think of this myself, but when he said this in class, I was like, Pedro, that's like the best idea I've ever heard. So now I'm going to explain the science behind this extra special trick. And it's so smart, I don't even know what to say about it. Not my idea. I'm just smart enough to recognize good ideas when I hear them. So you ready for this? Biochemical reactions involving the transfer of methyl and related single carbon units are necessary for synthesis, regulation, and clearance of DNA, RNA, proteins, neurotransmitters, and hormones. So what we're talking about here is more than just mitochondria. We're talking about DNA regulation, proteins, which are of course related to mitochondria, your brain, and your hormones. However, the large majority, approximately 80% of methyl activity is directed at the production of creatine. Now, if you read recent papers on this, it'll say anywhere from 50 to 80% of methylation is devoted to the production of creatine. I'm going to say that again. Somewhere between 50 and 80% of all the methylation that your body's doing, the vast majority of what you're methylating, how you're using methylation, is in the production of creatine. The universal source of immediate energy as phosphocreatine. So if I'm gonna like go take a bike ride and some, person passes me and I get all aggro about that. I'm like, I'm gonna catch them. And I go as hard as I can on my bike for 30 seconds and then I collapse because I'm old and tired. That 30-second all-out push, you're using a special kind of immediate energy from the muscle, right? This is this whole phosphocreatine thing. Another 30%, 20-30% of methylation is related to making and maintaining cell membranes. Okay. So 50% plus of what you're methylating has to do with creatine production, 20-30%, something like that, has to do with membranes. There's another diagram that shows in detail, here's your creatine, here's your methylation. Here's your phosphocreatine and making of energy for the brain. And it's kind of loosely involved with arginine, but we're not really talking about that. So now why does this matter? Because you can use creatine as a supplement. And there's all kinds of research on this you want to read about. Here's just one of a million studies here. But you can use creatine as a supplement so that 50 to 80% of methylation that usually goes towards creatine production doesn't have to happen because you're taking it as a supplement. So guess what? Your availability for methylating other things is going to be there. It's an indirect way of making sure that you can methylate other stuff as you're giving all this creatine to your system so your body doesn't have to devote all this time and energy to making the creatine. That's a pretty amazing, simple way to fix things. And then the other thing I always want to call out here, and I was taught this by Nathan Morris, a good friend of mine, who is an expert in methylation, never forget choline. Nathan always used to say to me, it's the most often missed product in the methylation program. There's no specific lab necessarily that's going to tell you they need choline. Just always give the person choline. Nathan taught me that, and he's right. You don't want it to undermine your program. Always give the person some choline as part of the program, and some betaine. Okay, anytime you're wanting to work on methylation. Now, the second component of this, we talked a lot about methylation, is glutathione. Why is glutathione important? Because glutathione is protecting your metabolism. When you're making energy, you're generating oxidative stress, and that creates a haze of free radicals that are going to damage your mitochondria. And you want a lot of glutathione to prevent the damage to mitochondria. I love this diagram. It's an oldie but a goodie. You can see this is the healthy mitochondria. And you see the unhealthy one, it's damaged. You see like the holes here. It looks like a bullet hole went through here, you know, or someone ripped it or something. Okay, so you don't want mitochondria that look like this one. You want mitochondria that look like this one. And what keeps your mitochondria young and healthy is the protection that glutathione offers to us. And if your mitochondria are becoming damaged because of not enough glutathione, then that's going to damage your metabolism, and you're not going to be able to burn fat very well. And this is what's happening to 90% of the American population right now. Excessive oxidative stress from environmental toxins, chemicals, and heavy metals, damaging our mitochondria. We can't burn fat well. We don't make energy well. We get tired and overweight, pre-diabetic, diabetic, have cardiovascular disease, and all these problems stacking up because we can't make energy right. So one enzyme, I'm just picking on one because there's dozens of them. We don't have that much time. If you were in the mentorship, you would be learning about all the important enzymes, but we don't have time right now. So don't forget, sign up for the class. You guys, somebody sign up for the class. Yesterday, a bunch of people during the call signed up for the class. I was like, yes, that is great. We want to have new practitioners that we can train, make you guys experts at interpreting labs. 20 years of doing this, $2,700 off. Don't hesitate. New year, new you. Get your practice kicked into gear. Sign up here. You get this QR code thing. You need this KI 2026 at checkout. If you get confused, you can't find the QR code, you can email my team. And it expires on the 15th, so get on it. I guess you have like a week or so to make up a decision. But I don't know. Talk to somebody that's taken the class if you can find someone that you know that's done it. It's just people do not think that it's always a good idea. If you're at the right time of your career to do this, it's going to be a good idea. All right, so here's the enzyme, succinate dehydrogenase. So when we see the lab markers, we see on the lab succinic acid. If that's high, it means this enzyme's not working. I'm just going to pick on this one enzyme because it's an interesting enzyme. So succinic acid goes high, meaning succinate dehydrogenase isn't working well. And succinate dehydrogenase is at the centerpiece between the electron transport chain and the citric acid cycle. And you can see this literally in this diagram of it. So this is the electron transport chain up here, and then the citric acid cycle is kind of down here circulating. So succinate dehydrogenase is an enzyme that is relevant or important for both of those processes. And the reason why succinate dehydrogenase is so interesting is because it is easily damaged by environmental toxins. Why? I don't know. It's just susceptible to this. It's like the weak link in your energy production chain. So environmental toxins out here can easily get in and damage this enzyme. And then what happens? Succinate will go high. Fumarate on the organic acids will either be high or more often low. And the main nutrients that are involved in all this are riboflavin and CoQ10. So this is a very important enzyme. And if it's not working right, your metabolism is going to be screwed up completely. Okay. And then this is a shout out for B vitamins. We're going to look a lot of about we're about to look at is going to be related to B vitamins and the use of B vitamins. And then these are the big nutrients that you need to learn how to dose: CoQ10, magnesium, B vitamins, and carnitine to get these metabolic problems kicked in. And then you need to figure out on the glutathione side how you're going to work with glutathione. And two things I'll say. One is that there's 3 amino acids from which you make glutathione, and the easiest way to get glutathione levels to skyrocket is to give cysteine and glycine together. Simple. Usually cysteine is sold in the form of N-acetylcysteine or NAC, and then glycine is just plain old glycine. You can do just the NAC by itself, but it works better if you pair it with glycine. Nobody ever gives glutamine to support glutathione production, even though it's one of the 3 amino acids that you use to make glutathione. So when your body needs to slap together a glutathione molecule, it takes glutamine, cysteine, and glycine to make that glutathione. Why does nobody ever use glutamine? Because there's so much glutamine in your system, it's just not considered a rate limiting step. Cysteine and glycine, much more important. So either there's some supplements that have both of these in them together, the cysteine and glycine together. Sometimes people use them separately. And depending on how bad the labs are, you want to really crank the dosages up. Now, none of this will work if the person has low magnesium. None of this will work if the person has low magnesium. So all this effort that we might put into making more energy, trying to get the person to make more energy and lose weight, if you provide the most beautiful amount of glutathione and you fix all the methylation pathways, if the person's low in magnesium, they won't be able to make ATP. So magnesium is sort of a backbone product in all of these programs, and it's required in order for glutathione to work properly. And there's a whole section in Richard's book about this if you want to read about it. He calls it the magnesium glutathione dyad. Glutathione will not get the job done if magnesium levels are low. So always pair magnesium with glutathione. If you get a patient in who's taken magnesium forever and they never seem to benefit from it, the reverse is true too. Magnesium won't work if your glutathione is low. And glutathione won't work if your magnesium is low. So if someone's taking glutathione and it's not working, give them magnesium. If they're taking magnesium and it's not working, give them glutathione. Those two are paired together, intimately paired together for all time. And in fact, this has saved me in so many cases, this one little thing. So I just want to kind of explain it. Let me just show you a different slideshow for 1 sec. These little tricks really help. Okay, here you go. So if let's say that you've got everything set for mitochondrial production. You found that the succinate was high. So you got all the chemicals and metals out of the system, and you got the glutathione levels coming up. You got all the B vitamins working, and methylating is working well, and everything's looking great. If you don't have enough magnesium, you can't make energy. It just won't work. The reverse is true too. If the person is taking a ton of magnesium and you're trying to use that so they make more energy, the body has sensors that can tell if you have adequate glutathione or not. There's all kinds of complex mechanisms. Your body is reading these signals all the time. So if your glutathione levels are low, even if everything else is working right, you will not make more ATP. Your body knows. Your body is just looking and going, wow, I got everything I need here to make ATP, except for glutathione levels are low. And then your body's thinking, well, or your cell really is thinking, well, if I made more energy right now, that would cause a ton of oxidative stress. And glutathione's already low. That would kill me. This is a cell thinking. That would kill me. So I'm not feeling suicidal today. So guess what? I'm gonna lay off on making energy. I'm gonna slow down all my mitochondrial functions because I don't have enough glutathione. You could fix methylation and fix magnesium. Your body will not make more ATP until you get the glutathione levels up. So magnesium and glutathione are paired together, and the reverse is true as well. If you get glutathione dialed in perfectly and you don't have enough magnesium, it's just going to be like a stuck situation. Okay, we're right on time, which is great. I just want to show you one other thing here to tie this together. This is a whole different slideshow, but I just want to show you a couple slides from here. So this is fresh out of the mentorship. So there's 6 different detox pathways in your liver, and we're talking right now specifically kind of loosely about 2 of them. So I just want to put this into a context for you. And you kind of got to memorize these 6, and they are glucuronidation, glutathione conjugation, sulfation, methylation, acetylation, and amino acid conjugation. All that this really means is that in glucuronidation, you take a glucuronic acid molecule and cram it onto a toxin and get rid of it. In glutathione conjugation, you take a glutathione, cram it onto the molecule to get rid of it. In methylation, you take a methyl group, the single carbon thing, right? Cram it onto whatever it is you're trying to get rid of to metabolize it and break it down. So we're focusing just on methylation and glutathione now. And of course, glutathione has many other roles, and methylation has many other roles. We're like pigeonholing them, but they have other roles. But I also just want you to see that there's a context here, and that it's not just about those 2 functions, and that here, this is my favorite version of it, yeah. And that all 6 of these pathways ultimately need to be working. So glutathione is the protector of mitochondria as an antioxidant. It also is running its own phase 2 detox pathway. Methylation is responsible for turning your DNA on and off, for making hormones, neurotransmitters. It's also on its own a detoxification pathway. So when you're talking about glutathione, it has a whole bunch of other roles outside of the narrow spectrum we're talking about now. And when we're talking about methylation, it has hundreds of other roles besides the role we're talking about now. And why am I even going on about this? Well, because if you find that glutathione levels are messed up and methylation is messed up and you fix those, you're looking at a universal correction for so many different pathways and problems that you probably couldn't even study it all. You probably couldn't even figure it out if you spent a year in some PhD programs trying to study what would actually happen. So if you just fix methylation and glutathione, you're fixing literally hundreds of potential processes in the body. And that's a good thing, way beyond what we're talking about now, because these, compounds like glutathione and this process like methylation, they do a lot of other stuff. And that's why Richard, in his opinion, these are the 2 most important things to correct for anybody. It doesn't matter what their health problem is. Okay, so let's go look at some labs now. Oh, and sign up for the class. I know one of you will do it. Maybe 10 of you will do it. Class starts in a week. And let's look at some labs. All right, so here's lab 1. Oh, look, it's in the right page too. Okay, well, that's handy. This is a organic acids profile. If you're wondering about the lab company, it's from Diagnostic Solutions. And let's look at here first. Now, we talked a lot about the citric acid cycle or Krebs cycle. Now, and I mentioned and I showed you this enzyme, remember? Succinic dehydrogenase or succinate dehydrogenase, that's the enzyme right there they're mentioning. When that marker goes high, succinic acid goes high, it shows that the enzyme's not working right. And then fumaric acid, remember that was the one right after it. This is what we're measuring. We're measuring how well that enzyme's working. Uh-oh, it's low. What does that mean? That's not good. Low is not good either. Low means there's not even enough of a reaction happening to cause the stress of the high marker. Bad, bad. That's like extra bad. And then let's look at our other markers here. And in order to take the mystery out of it, they actually label these for you, so you don't have to memorize this, but you need to learn it anyways. Methylmalonic acid, that's the B12 marker. If it's high, it's a problem. Folate, the marker is FIGLU. They've got it spelled out there for miminoglutamate. If it's high, it means there's a problem with folate. And then vitamin B6, they have 2 markers. This is the one that we looked at earlier, xanthurnic acid or xanthurnate. If it's high, there's a B6 deficiency. So this is like methylation central here. However, now we know that there's a lot more happening. If you see these markers messed up, that's not enough to understand the methylation process. And in fact, if these markers are all normal, like they are here, could the person still have a big methylation problem? Heck yeah, we just spent like an hour talking about that. What if their amino acids are low? One of those 5 amino acids I mentioned. What if they're low in choline or betaine or methionine? It doesn't have to be a B vitamin deficiency that's creating a methylation defect. And as we just learned, let's look at this person's glutathione markers. Here we go, glutathione status. Again, there's no mystery here. They kind of call out exactly what this is about. Alpha hydroxybutyric acid, I showed that one on the image a while ago, is high. That means glutathione levels are low. Pyroglutamic acid is low. That means glutathione levels are low. So if glutathione levels are low, is methylation great? Think about it, remember? No, it can't be. Because if glutathione levels are low, it means that methylation has already been impacted. We're just not seeing it in a really clear way on the test yet. But you're seeing it indirectly by understanding the glutathione status. So again, glutathione and methylation are paired together. And when you're going to support glutathione, like you are with this patient, you also want to support magnesium. All right. So let's look at, well, let's just, let me see if I can design a program first, just so you see how this might work. Now, if you were in our amazing mentorship class, you would be, you know, submitting labs and doing this with your own real patients. Then you'd be coming back a couple months later. We had a couple this yesterday morning, I guess, submitting the follow-up testing and saying, I don't really understand this follow-up test. Like, okay, that's kind of complicated. So, I mean, it's one thing to interpret your first organic acids profile, but when you do a second one 6 months later, really, it's like 10 times harder to interpret the second one. So let's just take a look here. Let's say, I'm going to kind of use this case loosely, low glutathione. And let's go down here. Just use this space here. So let's say this person has low glutathione. What are we going to do about that? So N-acetylcysteine, typically it's used, it comes in a 900 milligram pill. So you can do like one of those 3 times a day. That would be about 3,000 a day. Glycine, I mentioned, you can do with it. Comes in a 500 milligram. You can also do anywhere from 1 to 2 of those. So NAC and glycine together will help bring up glutathione. If for some reason you don't want to do that, you can just use glutathione. Usually it's in a liposomal form. At 100 milligrams, you could do 1 to 2 dosages of that twice a day. So either NAC and glycine together or liposomal glutathione. And anytime you're going to recommend either of these strategies, remember, you're going to use magnesium. I like magnesium glycinate. It's easily available, but you may have your other favorite form of magnesium. Obviously, magnesium glycinate has glycine in it, so that's kind of handy, isn't it? Because the magnesium is bound to a glycine molecule, so you're getting some extra glycine from that, which the person needs because we're trying to get their glutathione levels up. So here we have the glutathione boosting strategies, either NAC and glycine or glutathione itself, and then always pairing that with magnesium. And then to round this out, you always want to use a B complex with the methylated Bs. Either 1 a day or sometimes as much as 1 twice a day, depending on how much you want to support methylation. That's a pretty complete glutathione boosting program. Now, if we want to take it from the opposite perspective, which could easily happen, let's look at that. Sorry, here, let me pull this up. Here we go. So the opposite perspective would be a methylation program. So now we're thinking about how can we support methylation. So B complex, the special methylated kind. I always use B supreme from Designs for Health because it has some choline in it and it has some betaine in it. I think that's kind of handy. So usually 1 a day. You need some extra choline. Usually that's at 1 a day. If you really want to go for it, you can use something like homocysteine supreme from Designs for Health. That's going to have even more of the B6, B12, folate, and a ton of trimethylglycine. 1 of those once a day or twice a day. Now, depending on where the labs take you, you may also want to use methionine or SAMe. If you're doing some more advanced testing, you may, as we just looked at, you may want to use glycine or glutamine or even tryptophan. Those are some of the amino acids that help you make the single carbon pool up. Oftentimes people use some antioxidant protection support, etc. And then you would always pair this methylation support, depending on the lab, with the glutathione support. And as we saw from the very beginning, the very first slides, it's the balance between your body trying to increase glutathione and deal with methylation. And so you can push it on both sides depending on what the testing shows. If the testing shows both methylation defects and glutathione problems, then you can work on both at the same time. No problem. In fact, that's probably usually what ends up happening. So here's another test. This is a metabolomics from Genova. Metabolomics. To give you another example of a different lab format. So now again, on this one, they have the whole citric acid cycle mapped out, so we can talk about what we looked at yesterday and today. So fatty acids, are they burning fat well? Is beta oxidation working? In this case, yes. And what's the key nutrient there? You see the Mg, that's magnesium. Carbohydrate metabolism, are they going through glycolysis well? No. Pyruvic acid and lactic acid are both out of range. See the little Mg there? Magnesium. It's essential for that reaction. You go down a little bit to the citric acid cycle itself, and you see all these different enzymes represented here with these markers. So succinic acid, we talked a lot about. If that goes high or low, you have a problem. And what do you see here? Mg, magnesium here. Mg, magnesium. And then perhaps where magnesium is the most important in some ways is down below here. Remember the electron transport chain? We had to all learn this. You had to memorize this 10 times in the different classes we all took, where you've got the ADP to ATP thing, and that's all magnesium dependent. So magnesium is all over the bottom part of this as well. I should do an infomercial for magnesium. So in other words, you have to have magnesium to burn fat, burn carbs, run the citric acid cycle, and run the electron transport chain. It's literally the key ingredient in all of those processes. So what's the solution there? Honestly, for the last 20 years, I just give every single new patient magnesium as part of a multi-pack. I think it's the easiest way to deal with this. And then if they need extra magnesium, you can give them some additional magnesium. Now, this particular lab measures glutathione as well as lipid peroxides and some other antioxidant markers like CoQ10, et cetera. So that's kind of handy. And let's look at some of the markers here. So here we have cellular energy. In this case, let's look at methylation. That's up here, sorry. Here. And it's kind of divided up funny in this test, but let me just circle the markers here. So you can see the key methylation markers you'd look at first, FIGLU for folate. If it's high, it means they have a problem. Methylmalonic acid for B12. If it's high, they have a deficiency. And they buried the B6 down in here. Xanthurnic acid, if it's high, they have a B6 problem. And kynurentic acid is a little confusing, but if it's high, it can also mean there's a B6 problem too. B6 is pretty important. And then down here, they have, you got to kind of hunt around for these if you're using Genova, which is a great lab company. You just got to hunt a little bit. Here's the one glutathione marker, pyroglutamic acid, that we talked about. That's low. It means glutathione's low. And you got to go like on a journey here, follow the line. Ding, 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 ding. You got to go on a long journey all the way over to carbohydrate metabolism to see the alpha hydroxybutyric. That's the other glutathione indicator. They're not exactly right next to each other, are they? No. So if this one is high, it means glutathione is low. If pyroglutamic is either high or low, it means glutathione is low. So those are two key glutathione markers. And then there's one other very challenging glutathione marker. That's a joke, not really, but it's just glutathione itself. So this lab actually measures glutathione. Where to go? I'm not finding it here for some reason. You might have to trust me on this one. They have a glutathione marker on here. It's just not popping up for me. We can see it up here. They put it on the graphic here. See this one here, glutathione? Okay, that's buried down in that other data as well. So you can see glutathione levels for glutathione itself, as well as seeing pyroglutamic acid and alpha hydroxybutyric acid. All of those are included. So you get a very cohesive view of what's happening with your glutathione levels. Now, questions? While we wrap up here, let me pull up this so you guys can get the QR codes. And let's see if we have some questions. We got like a minute or two here. A couple of people here have questions. So for Marcy's asking about stage 3 kidney disease. Yeah, for people that have advanced kidney disease or any level of kidney disease, you have to be extremely careful with supplements. And none of the rules that we're talking about here today apply. So if they have kidney disease, honestly, I don't know that I would supplement at all unless you're a specialist in that area. You're very likely to make the person sick. So what's the best form of magnesium? So I like the magnesium glycinate because it has the glycine in it, which helps with glutathione production. So it's a magnesium molecule bound to glycine. The other really popular one now is magnesium threonate. Magnesium threonate is more targeted for the brain. That's really not what we're doing here. We're doing more of a metabolic reset, but magnesium threonate can work really well. And the other thing about magnesium is that it comes in a powder form, which can be really helpful if you're trying to keep the number of capsules or pills down. So you can get magnesium in a powder, vitamin C in a powder, and acetylcysteine and glycine together come in a powder. Pure Encapsulations makes that. I use that product all the time. It's NAC and glycine in a powder from Pure Encapsulations. That's a great product because that takes care of like 1 scoop of that stuff twice a day eliminates the need for 12 different capsules. So again, it's NAC glycine in a powder form. And they make mitochondrial support, general mitochondrial support in powders. Orthomolecular has one called MitoCore, which is really good. So there's lots of ways you can support people if you want to avoid, using too many pills. And let's see. So there's many. So Becky's asking about the different types of markers for glutathione. So there's many different ways that you measure glutathione. There's the glutathione levels themselves. And then there's the micronutrients, but you're not always going to see everything correlate really neatly, unfortunately. Okay, there's going to be times when, let me show you here. I have it on the diagram. So think of it this way, like you're hunting for any signs of low glutathione. Not everything's always going to line up really neatly. It's just not how the body works. So sometimes you're going to see glutathione itself low. Then it's pretty easy. You might see normal glutathione, but really low pyroglutamic acid. That still means that their glutathione levels are low. You can see that pyroglutamic acid is a byproduct of reduced glutathione. In some people, you don't see the reduced form low, so pyroglutamic is fine, but the oxidized levels are low. And sometimes it happens in the reverse. So you don't always get a complete correlation here. You can have pyroglutamic high or low, that means low glutathione, but it's on the reduced side. And you can have the measurement of actual glutathione low, which means this is low. So anyways, they're not always going to correlate. And then way over this away is your alpha hydroxybutyric acid. If that's high, that's an indicator of low glutathione. And these things happen in stages too. When your glutathione levels are first getting screwed up, this is the first marker of the go. Alpha hydroxybutyric goes first. Later, when it's getting worse, pyroglutamic goes high. Later, after that, when it's getting even worse, pyroglutamic goes low. And then eventually, if it's a complete disaster, the actual glutathione itself drops. So there's stages to this. And if you were in the mentorship, I would teach you this, how you can look at all these different markers and figure out what stage of glutathione depletion they're in. Is it the beginning stage or more advanced stage? That's a handy thing to know because that's going to help you get the dose right. So if you give somebody who's in an advanced stage of glutathione depletion 1,000 milligrams of NAC, I guarantee you they could do that for the next 27 years, and it's not going to help even a little bit, not even a little bit. If you give someone in an early stage of glutathione depletion 1,000, it might help. You might get lucky, it might help. If they're in an advanced depletion state of glutathione, and this marker is off, and this one is low, and this is off, then you're talking, you know, at least 3,000, 4,000 milligrams of NAC a day, plus the additional glycine to move the needle. And you want to do it safely, so you want to give the recommended amount for 3 to 6 months, stop and retest. And you don't want to use these really high therapeutic dosages unless someone's looking over your shoulder. That's the whole point of the mentorship. When I was learning this stuff, I would never have given anyone 4,000 milligrams of NAC. I would have freaked out. It would have been dangerous. But I had Dr. Timmons on my speed dial on my cell phone, and I would say, hey, Bill, what should I do? He'd say, give him like 3,000 milligrams. I say, are you sure? I would always say, are you sure? He's like, yeah. Okay, thanks. I'll call you back tomorrow. So you got to have somebody that's done this for a while that's telling you dosages, or you're going to get into some serious trouble. You're going to get into two kinds of trouble. You're either going to underdose people perpetually and nothing's going to change, and you're going to redo the testing and you'll be like, wow, the labs look the same. Now that's depressing. You're not going to stay in practice very long if you're not helping people. And then if you're overdosing people, they're going to go to get sick and go to the emergency room. You're going to get arrested. So that's not a good idea either. So that's the whole point of the mentorship, is we want to give you guys mentoring. Dr. Timmons spent like 8 years mentoring me. Dr. Lord spent almost 12 mentoring me. I've had these people in my life. Dr. Glenn Frieder spent like 5 years. I've had 3 mentors, all of whom spent many years telling me what to do and how to do it safely. And I'm trying to pass that on with this program, so this next generation, you guys, can know what these protocols are, ones that are effective, and safe. But you don't want to play it too safe, because then you don't get any changes. And that's kind of the whole point of the class, all right? Okay, so let me see. A couple other questions. We're going to wrap it up because we're right at time now. Let's see. High succinic and the need for carnitine. What do you do with someone on thyroid meds? That's too complicated to answer without a 10-minute talk. So I don't want to answer that for Cami, because there's probably an answer, but I'd have to know more about that. You have to be, carnitine has a poor interaction with thyroid medications, so you have to be careful about that. The easiest thing is just to not use the carnitine. Let's see. The other question here is a little complicated too. It's from James. If a patient has alpha hydroxybutyric acid, pyroglutamate acid marker is normal to low, but intense symptoms of fatigue. No, you could have horrible problems of fatigue and not have it not be related to glutathione at all. It could easily be a neurotransmitter problem, a thyroid problem, an adrenal problem, etc. And that's the whole point of doing a spectrum of labs, is if you do hormone testing, a Dutch test, or an adrenal salivary test, a really good GI workup, and organic acids, fatty acids, amino acids, then you start to see the whole picture, and you can hone in on, like, why is that glycine helping this person so much? Or is it really a glutathione problem? And being able to juggle multiple labs will help save you a lot of clinical time, ultimately, when you're working with patients. All right, I'm going to wrap up now. Take care. I'm looking forward to speaking with some of you next week in the mentorship class. Check out the QR code, and we'll talk soon. Bye now.